performance of steam generators or performance of boilers. Equivalent evaporation. It may be defined as the amount of water evaporated from water at 100 degrees Celsius to dry and saturated steam at 100 degrees Celsius. Consider a boiler generating mkg of steam per hour at a pressure P and temperature T. The equivalent evaporation can be defined mathematically as follows, where H represents enthalpy of steam per kg under the generating conditions and HF is enthalpy of water at a given feed temperature. Factor of evaporation. It is defined as the ratio of heat required by 1 kg of water under working conditions to that received by 1 kg of water evaporated from at 100 degrees Celsius. It is denoted by Fe, factor of evaporation. Mathematical representation is H minus HF by 2257. Boiler efficiency. Boiler efficiency is the ratio of heat actually utilized in generation of steam to the heat supplied by the fuel in the same period. Mathematically, boiler efficiency can be expressed as follows. Heat losses in boiler plant. The following heat losses occur in boiler plant. Heat lost to the flue gases. The flue gases contain dry products of combustion as well as the steam generated due to combustion of hydrogen in the fuel. Heat lost through dry flue gases can be calculated using this equation, and heat carried away by the steam in the gases. This steam in the flue gases will be present due to the combustion of hydrogen in the fuel. So finally the total heat lost to the flue gases is the sum of heat lost through dry flue gases, heat carried away by the steam in the flue gas. Then heat lost due to incomplete combustion. The combustion is said to be incomplete if the carbon burns to carbon monoxide instead of carbon dioxide. 1 kg of carbon releases 10,120 kilojoule of heat if it burns to carbon monoxide, whereas it can release 33,800 kilojoule per kg if it burns to carbon dioxide. If all the carbon content in the fuel completely converted into carbon dioxide, then heat release will be more. Because of the incomplete combustion, the heat release will be less, because if there is an incomplete combustion, some of the carbon particles will be converted into carbon monoxide instead of carbon dioxide. This heat lost due to incomplete combustion of carbon per kg of fuel can be calculated using the following formula. Then heat lost due to unburnt fuel. If Mf is the mass of unburnt fuel per kg of fuel used and C is the calorific value of the fuel, then heat lost due to unburnt fuel is calculated by this formula. Then finally, convection and radiation losses. As the hot surfaces of the boiler are exposed to the atmosphere, there will always be a heat loss to atmosphere by convection and radiation. This can be calculated by following formula. The loss of heat due to convection and radiation losses is equal to heat released per kg of fuel minus total of the heat loss. Total of the heat loss means whatever the heat losses we have discussed earlier, that is equation 14.4, 14.5, 14.6 and 14.7. The loss of heat due to convection and radiation losses is equal to heat released per kg of fuel minus sum of all these equations. And I have solved some of examples, numericals on boiler performance or steam generators.